again, I'm just gonna I'll go like old school or just not use my guided notes, and I'll just, I'll use the marker board or something. All right, so separated by addition and subtraction is how we decide what a term is. So we're going to talk about how we name these. We're talking about polynomials today. If you guys recall, last chapter we talked about monomials, so one term. Polynomials is many terms. So we're going to talk about what happens when there's one term or two terms, three, and then after four or more, we just start calling them kind of all in one group. So an example of one term is like what we talked about all last chapter. So this is like 7x to the third y. So that's considered a monomial. So that's what we talked about last chapter, all one term. Now again, terms are separated by addition and subtraction. So once I throw an addition or subtraction sign in there, then it becomes another term. So something like this. So I threw a plus sign in there, and now it has two terms rather than just one. Any ideas what we call that? Oh my gosh.
Yeah? Today's going to be a fun day. This is going to be great.
Seriously, this hasn't done this to any other class. It's just you guys that doesn't like.
That's because we're all probably not. Well, it doesn't get any. Clearly, we're just too swaggy to call it.
Okay. What do you think we call that? Yeah. Binomial. So mono is one. Bi, you think like a bicycle has two wheels.
Clearly, I'm just too good.
So binomial. Now what we're going to do is we're going to add another like sign. So now I added a subtraction. But now this has 1, 2, 3 terms. So it's the same values, but now I have those addition and subtractions separating it. So trinomial, like a tricycle.
Who in their right mind would ride a tricycle? You. I would not.
There's a boy that goes to my kid's school that rides a unicycle to school. Like just the one wheel. Like.
Yeah, well, good. I can't do that.
He lives really close. Like
Wait, where does they go?
They go to school in Grafton.
Oh,
But-
that explains it.
Those things can actually go pretty fast.
Well, he only has like about like, I don't know, it's less than a block. He lives like just on the other block that we live on.
So you write the
But he rides a unicycle. It was really funny because the one day Griffin got his contacts, we walked him back to school because we lived that close to walk, and like on the bike rack was the unicycle like leaning up there. It just looks so funny, and like you see him going down the street. So talented little guy. So my kids do not ride unicycles.
I don't know. I wouldn't know about that. I wouldn't be that surprised.
Okay, so a polynomial is 4 or more terms. So this one is 4 terms.
Oh, you should have
One.
put 7x, 3, and y.
Yeah, I could
You
have.
worked so well.
So this has 4 terms. So rather than calling this like a quadrinomial or something like
That would
that,
be so cool.
we call it just a polynomial. So anything over 4. I'm spelling it wrong.
Yeah, I don't think your board's gonna work again.
No, I know, it's being really finicky. Now, technically, all of these are polynomials.
If they're
So,
added together.
any kind of monomial or nomial isn't really a polynomial. It's just we want to use the more specific names if we can. Just like if I walked into class and said, hey students, and then like I needed to talk to one of you, I would use your specific name. So just being like, student, stop, talking out of turn, that would be weird. I'd want to say specifically, who I was talking to.
Oh, that'd be pretty funny.
So, we're going to talk about what makes something not a polynomial next. So some of the things so not to be in this category. So these are all not polynomials. Yep.
Is it the top three?
No, they are polynomials.
I actually thought that was going to be it. I was going to.
Yeah, there's 3 bullet points, so it looks like.
Oh my. I thought you were going to write exploded and then please.
Okay. So an example of something that's not a polynomial is when we have a variable as an exponent. Now this is something that can happen eventually, like algebra 2 pre-calc world, but we're not going to deal with those, something with a variable as an exponent. We also can't have a variable in the denominator for a polynomial. Now we've had that, but then it's not a polynomial.
Isn't that like a mononomial? Is that what you mean?
Yeah, technically.
I don't know.
So this one, if I tried to have you guys work with that as a polynomial, you'd have to say that's not a polynomial, because there's a variable in the denominator. Now technically you could probably call that a monomial, but we don't need to get that technical. The next one is there can't be a negative exponent, which is essentially what we have going on here. Now all of these things are possible, it's just not considered polynomial. So like x to the negative 5 powers. These are all examples of things that aren't polynomials. Now we can do things with them, but they're not considered polynomials. And then if you have a little more space under that, we're going to add another vocabulary word. If you don't, if you can put it on the bottom somewhere or something is fine. The next thing we're going to talk about is something called the degree. So the degree, you think about that maybe, like, I don't know if it occurs to you, but like my geometry students use degrees all the time when they talk about the size of an angle. So if it's a 30-degree angle, that's not what degrees we're talking about here.
Are we talking about temperature?
No, not temperature either. So the algebra people have their own vocabulary words, so degree is something different. Guys, make sure your phones are put away. So it's the highest power on the variables. I'll show you guys an example of what I mean. I'll do a couple quick examples. Again, if you don't have space, you can use the margin or something like that. This doesn't require a lot of math. We're just looking at it. So the degree of this polynomial, this is a binomial, the degree of it is the highest power on the variable. So we'd say this is degree of what? 3. So we call this a third degree. Oops. Or a third degree word, no. Third degree polynomial. Sounds pretty serious. Now, if I take that plus sign away, this one's kind of strange. We won't do a ton like this. Now this is degree of 3 here, but what does the y have?
1.
A 1. So since that has a 1, this is technically degree of 4, because it's a 3 and a 1 together. So it's the degree of the variables. Now when we do this, sorry, that should be 4th degree. When we do this, it's among each term. So this is a separate term, that's a 1. So among all the terms, what's the highest degree? It's a little bit confusing. It's going to make hopefully more sense kind of in context. All right, let's get through the next example, and then we'll take a break because I feel like I've been talking at you for a while here. And I need to get the first half of the video online. So the first thing we're going to talk about is standard form. So standard form is when we take this polynomial, so this is a polynomial. We'll talk about terms in a second here. So this is a polynomial. We're going to write it in standard form. What standard form means is take the highest power and then write it all the way down to the lowest. So highest to lowest power. Hi. We have technical difficulties, so I'm a little behind on notes.
You're fine. Don't. Yeah. We're not.
Okay.
Yet. So.
Okay. Like the board hasn't been syncing, and it's like, because I think our internet's a little spotty.
Okay. Because I can't.
Yeah, no, the internet's spotty, so then that's how it communicates with my computer. So it kind of keeps like dropping off. Like I can tell that we're not at like full internet. So yeah, and there was issues yesterday
Trying to
too.
help him because we're working on it, and I can't see what he's doing.
Yeah, no, there's something going on.
Okay.
So yeah, we restarted, and
Okay. Well, I'm gonna-
they were, yeah.
Okay.
Okay. Oh, yeah. Okay.
So we're not even to.
No, that's good. Okay, that makes me feel a little bit better. Okay.
We've got a lap to do.
Okay. So, which is the highest power term? Highest power, highest exponent. Yep. Yeah, so this is the highest power. So we're going to write that one first. And then we're going to go down, like kind of sequentially down to the lowest. So the next one would be a positive x to the 3rd, right? 4, 3. And then you're right, so it's a positive x squared, because it's positive, we assume there's a positive in front here. What do you think should be next then? Yeah, that 5x is like a 5x to the 1st power. And then just the minus 2, because it has no variable at all. So this is considered standard form. So today when we talk about, like the book will ask you to write things in standard form, and throughout this chapter we're going to use standard form. That way we all are talking about the exact same polynomial in the same way. And like again, it's just kind of a standard way to write things. So like, that we all write scientific notation the same way. Kind of like we all like call each other, like it's the standard way I call you guys by your first names. That I don't call you like out of order or just use your last name or something like that. So crazy, yeah. So the next thing is called the leading coefficient. And think about like back in the kindergarten days, the leading coefficient is like the line leader. So it's kind of the front of it, the front kid. So when it's in standard form, it's going to be the first coefficient. I'm going to jinx it, but I'm saying it's actually working kind of good right now. And it's about to like freeze up on me. Knock on wood, where's wood?
door.
Door.
Is that real wood though? It's polished, so it doesn't
Okay.
not
So, in this case, the first coefficient is just going to be this. So the leading coefficient in this case is 2. So it's like the line leader. It was really important when you were like in kindergarten to be the line leader.
No, I always like
The caboose. I have a friend who's from England. She was born in Hong Kong, and then she went to school in England, in London. So she's Asian, but she's got this amazing British accent. So she's very, like, I just love talking to her. But she didn't know what a caboose was. Like, I was like, we were running and on like on a trail, and I was like, I'll be the caboose, and she was like, caboose, what's that? And, like, she said it in like the cutest way, and she's a very smart lady, like, so she, but it was just so cute because I didn't think about the fact that it's a word that maybe not everyone uses, especially if you're not from here. So the next thing we're going to talk about is classifying based on the number of terms. So how many terms is this? Did you guys figure that out already? How many terms would this be? What terms are there? There's 5, right? 5. 1, 2, 3, 4, 5 terms. So we call this one just a polynomial. There's not a name for something with 5 terms. It's not like a pentanomial or something like that.
What did you say? Polynomial was 4 or more? So that would be the name.
Yeah. It just doesn't have like a special name for being a 5-term polynomial. All right, classified based on the degree. So this one, what's the degree going to be? It's the highest, we wrote the highest power on the variables. What's the highest power? Just look at one of the each
Oh,
of the
wait, we're
terms.
not supposed to add up?
No, not only if they're all one term, you got them. So it's going to be the 4th degree, right? So this is the degree, this is the 4th degree polynomial. So some of the questions today will just be asking you guys questions like these. So what's the degree, how many terms, is it a polynomial or not? Now we're going to get into the adding and subtracting with polynomials. Now, we talked about adding and subtracting like terms previously. Back in our solving equation days, we added and subtracted like terms. Remember, like terms have the same variable, the same exponent on the variable, or they have no variable at all. So for instance, like 5x to the third and 2x to the third would be like terms because they have the same variable x, they have the same exponent on the variable, which is a 3, and they both have variables, so don't worry about the no variable part. Now when we go to add those two together, if you guys recall, we add or subtract the coefficients, so the numbers in the front. Whatever it tells us to do. So we're going to add those numbers in the front. So 5 and 2, we get 7. And then we don't change our variable at all. So leave the variable and exponent as is. So it's gonna be a 7x to the third. What's up? Oh. Oh, yeah, no, that's fine. So she remembers.
She can remember which one she did, so.
Yeah, no, that's fine.
Thank you.
Yeah.
Why did you, would you rather?
Yeah, oh yeah, we haven't done would you rather forever, hey? Yeah, why don't we do that? Forever.